last section in Chapter 4, Generalized Forwarding and SDN. So in these SDN routers, okay, the way we're doing forwarding is actually different from the traditional one, therefore we call it the Generalized Forwarding. In traditional routing, if you still recall, in the data plane, when packet arrives, we look at the destination IP address and we try to match destination IP address to the prefix entries in the forwarding table. If we match one, what we essentially do is to forward the packet to the link interface indicated in the entry. Okay. So in the traditional forwarding, what we're doing in terms of matching, very specific, the destination address. What we're doing as an action is simply to forward the packet further. But in SDN routers, in the data plane, the matching and actions are now a lot more general. This is the architecture of the modern routing, or SDN-based routing. Now the separation of data plane and control plane, this part is actually very similar to the traditional routing. Now, if you recall the overview of Chapters 4, you should recognize in SDN, the control plane look very different. Okay, instead of having routing algorithms running on each individual routers, we now run the routing algorithm centrally on one or maybe a couple powerful machines. And these machines could be slightly far away from the routers in the network. Now, what's a bit similar though between SDN routing and the traditional routing is this. After route computation, we generate tables like this. Okay, this is similar to traditional routing, right? In the control plane of the traditional routing algorithm finish computation generates forwarding table, and we install forwarding table to the data plane of the traditional router. Now, in SDN, tables are generated as well from the routing algorithm computation, and we also install these tables to the data plane of the SDN routers. You see, the control plane to data plane connection there between SDN and traditional routing, very similar. The only slight difference is this. In traditional routing, we call these the forwarding tables, but in SDN, we call them the flow tables. So each router there will be installed with these flow tables to handle packets coming in. And so a flow table, if we zoom in, it looks more like this in SDN. In traditional forwarding, we have what? Prefix, the first column, and the link interface, the second column. The actions being taken is very simple, matching prefix, and then forward to a link interface. So what we're doing is always forwarding in the traditional routing. But in SDN, these actions could be more general, okay? Not just forwarding. So calling it a forwarding table is a bit awkward. So instead, in SDN, we call it the flow table instead. And by flow, SDN is actually referring to each of these entries, each of these rows in the table. That is also saying if packets coming into this router, where multiple of them matching a particular header combination and therefore take the same action, they belong to the same flow. So each row here is a flow. So we have a table of many flows in a sense. So what I'm showing here is also an example. Packets could come in with the headers looking like this, the destination being 0100, source IP address being 1101. Okay. Now we need to go ahead and look up the flow table in this router, and then determine it should go out on interface 2 arriving at this router next. Now in order to do that, there needs to be an entry, let's say this one here, matching the destination and source address. So in the header column of this entry, there should be specification looking like this. D equals 0100, S equal 1101. Therefore, when this packet arrives, look up, we match this entry and therefore take the action here. Now, forwarding to interface 2, the action there should look like this. Okay, so matching this packet to the combination of header fields and take the action. Now, in the meantime, we take the action, this thing here. Okay, for this entry, the counters, both the packet counter and the data byte counter will be added. So packet counter will be added by 1 for one packet. Data counter will be added by the size of the data here in the packet. Okay, so you see, header column here for matching purpose. Last column here for action purpose. And counter here for management purpose.